Good morning, students. Today's topic is DFT as linear transformation. So here we represent the definition for the DFT in the matrix form. That means linear transformation matrix for the twiddle factors values. That means Wn also, and for the input or signals, what is that x of n sequence, and also for the frequency samples x of k. Okay, so now another representation of a particular DFT here. For that, so firstly we know that the definition of the DFT. What is that? X of k is equal to summation n0 to n minus 1 x of n wn power kn, and of course this wn is nothing but e power minus j 2 pi by n. Okay, now so expand this series summation, substitute n0, 1, 2, 3 and so on. Then you can get like this, substitute in the place of n different values. Firstly 0, next one is the n is equal to 1, next one 2 and so on. Here x of n minus 1 wn power k n minus 1, right? So now here what is the k range here? 0 to n minus 1. So now apply different values for k, 0, 1, 2 and so on. Then x of 0 wn power 0, x of 1 wn power 0, x of 2 wn power 0 and so on, x of n minus 1 wn power 0. Now x of 1 is nothing but x of 0 wn power 0, x of 1 wn power 1, x of 3 wn power 2 and so on, x of n minus 1 wn power n minus 1. So this is the equation. So substitute here. Okay, now substitute k2 in equation 1 again. So x of 0 wn power 0, x of 1 wn power 2, x of 3 wn power 6, 2 2s are 4 plus and so on, x of n minus 1 wn power 2 into n minus 1. Now similarly here for x of n minus 1, right, last value, x of 0 wn power 0 plus x of 1 wn power n minus 1 plus x of 3 wn power 2 into n minus 1 and so on, x of n minus 1 wn power n minus 1 into n minus 1, right? So that means if you observe these equations, so it's a linear what is that, a combination of here what is that, x of 0 with the coefficient x of n values with the coefficients twiddle factors. If you see, if you observe this equation, so x of 0 is nothing but, so what is that, x of 0 wn power 0 plus x of n wn power 0 and so on, like that. That means here we may write this particular equation in the matrix form, right? So here consider this one is a one vector and what is that, xk, and consider xn is one vector. So now and these twiddle factors also consider the n by n matrix, like that. So here we may represent all these equations in matrix form. So here observe. So firstly I am considering here like this. What is that? X of 0, x of 1, x of 2 and so on, x of n minus 1. That is the frequency samples. So here consider n by n total factor values as a matrix. Now input. So here input is x of 0, x of 1, x of 2 and so on, x of n minus 1. Here values are first row values. See this, wn power 0, wn power 0, wn power 0, wn power 0. That means here anything power 0, the value gives the 1, right? So that's why here wn power 0 is equal to 1. So here first row values, first row elements are all are equal to 1, 1, 1, 1, 1. Am I correct? So now see this, write like this, 1, 1, 1 and so on, 1. And then for the second row here observe, this one also 1, 1, this one is wn power 1, wn power 2 and so on, wn power n minus 1. So here 1, wn power 1, wn power 2 and so on, wn power n minus 1. So now see this third row, this one also 1, wn power 2, 4, 2 into n power minus 1, like that. That means 1, wn power 2, wn power 4, wn power 2, n minus 1. So similarly here, what is the last row here? See, this one also 1, wn power n minus 1, wn power 2 power n minus 1 and so on, this one. Okay, so write that one, 1, wn power n minus 1, wn power 2 n minus 1, wn power n minus 1, n minus 1. Okay, so now, so here in this way we can represent the DFT. So observe this one. This one. Okay, that means this is nothing but here we can represent like this, n a vector here, this one is w, consider like this, wn, this is this one. That means x is the vector from x of 0 to x of n minus 1. These are the samples for the sequence x of n, and then capital Xn is nothing but this one also vector, column vectors of course. So here frequency samples from x of 0 to capital X of 0 to x of n minus 1. Now wn is nothing but here coefficients, linear coefficients like that. So total factor values. So here this is nothing but the n by n matrix, n by n matrix. Okay, so now based on this equation also, that means after completing this matrix, so after calculating all these values, then after multiplying the given sequence values with this particular matrix, then you can get the frequency samples. That means we can get the DFT of the x of n, right? So this is nothing but the linear transformation, DFT as a linear transformation. This is said to be linear transformation matrix, size is n by n, linear transformation matrix with the size n by n. Okay, thank you.